Next lesson is on the relationship between moles and energy. And so here we have a thermochemical equation. So before we even attempt to do any calculation, let's interpret this value. So first of all, is this reaction endothermic or exothermic? So recall in a thermochemical equation, if the heat term is on the left side, the reaction is endothermic. And if the heat term is on the right side, the reaction is exothermic. So this reaction is exothermic. So here's another question for you. How much energy is released during this reaction? Answer that question. Well, it's a trick question because it depends on how much of the reactants react. The more NH3 and HBr you have that react, the more energy is released. And the opposite is also true. So what is this 180.32 kilojoules? What does that actually mean? So that number, very important here, that number is relative to the amounts of each of the substances involved in the reaction. Meaning 188.32 kilojoules of energy is released per every 1 mole of ammonia that reacts, or 188.32 kilojoules of energy is released per every 1 mole of HBr that reacts, or 188.32 kilojoules of energy is released per 1 mole of ammonium bromide that forms. So that number is relative to the amounts of each of the substances involved in the reaction. So now for this particular problem, what do we care about? How are we going to use that number? Well, we're given 30 grams of ammonium bromide, and so we want to do something relative to the amount of that substance. So what we're going to do, and you'll see in just a second, is we're going to use this heat term as a conversion factor, a way of converting between kilojoules and moles. So we can go from moles to kilojoules, or as we'll see next, from kilojoules to moles. So for now, let's start off with 30 grams of ammonium bromide. Okay, so what do we need to do with that? Our first step is to take that and convert it into moles. So remember that heat term is relative to the amounts of each of the substances in moles. So let's calculate the molar mass of ammonium bromide. Looks like we get about 98.0. And then our next step is to find the energy, total energy released. So 188.32 kilojoules. Let's try that again. Now be careful here. So again, this number here is relative to the amounts of each of the substances involved in the reaction according to the chemical equation. So 188.32 kilojoules of energy is released per how many moles of ammonium bromide? Well, in our balance equation, we have 1 mole. If that was a 2 in front of the NH4Br, we'd put a 2 here, but it's not. It's a 1, so it's per 1 mole. Go ahead and pause the video and do this calculation. End up with 57.6 kilojoules released. Sometimes you'll see on the answer key. The question asks for how much energy is released, so we can just put a number there. So notice that we have 30 grams of ammonium bromide. That's far less than a mole. So that's even less than a third of a mole. So you're going to release about a third of 188.32 kilojoules, so a little less than 60 kilojoules released. That's how we interpret that. All right, let's take a look at the next one. What mass of CrO3 reacted if 16 kilojoules of energy were released according to the following equation? So this time we're starting with kilojoules. So let's do that. And so we want kilojoules to cancel. So again, this reaction is exothermic. So let's put 5.4 kilojoules there. Now, 5.4 kilojoules per what? So what substance are we dealing with here? We're looking for the mass of CrO3. So we want moles of CrO3 on top. So according to the chemical equation, 5.4 kilojoules of energy is released per how many moles of CrO3 that reacts? That would be 1 mole. So kilojoules cancels. Next step is to answer the question. Molar mass of CrO3 is 100. So we'll put a decimal there after the 0, so we make 3 sig figs. And go ahead and pause the video and see what you get. Your calculator is probably going to give you around 296, whoops, that's grams, 296 grams. But if we look at our heat term, we have 2 sig figs. So we want to round this to 2 sig figs. That does not work because that's only 1 sig fig. So how do we round 296 grams to just 2 sig figs? Can't put a decimal at the end of that 300. That would be 3 sig figs. So the only way here to do this is to put it in scientific notation. So we get 3.0 times 10 to the second grams. All right, one for you to do. Notice I changed this problem up. I wanted to make it a little bit more complex for you, a little bit more like what you will see on the test. So instead of molecules of chlorine, I changed it to how many formula units of sodium bromide. So that's what we're looking for, formula units of sodium bromide. So we're dealing with that substance there. Would be needed to produce 95.0 kilojoules of energy according to this equation. All right, go ahead and pause the video and set that up. So take a look at our first conversion factor. Again, very, very important, easy to miss. A lot of times students will just automatically put 1 mole in that conversion factor. So gotta know this is relative to the amounts of each of the substances involved in the reaction according to the balanced equation. So 100.18 kilojoules of energy is released per every 2 moles of sodium bromide that reacts. So we need a 2 there. And then we want formula units, so we're going to use Avogadro's number, and ultimately we end up with 1.14 times 10 to the 24th formula units of sodium bromide. All right, short and sweet there. That concludes our lesson. I'll give you a chance to do some practice problems with that. Thanks for watching.